Another important example of when to use comparing real and imaginary parts is when you're finding the square root of a complex number. We're going to look at a different way of doing this later on in the course, but one way of doing this would be to say that actually, let's say that the square root of 3 plus 4i is a complex number, because it is going to be a complex number, and let's say that it's equal to a plus bi. So we're just saying that it's equal to some complex number a plus bi. And here we should say a and b are both real, because that's the definition of a complex number. The real part plus the imaginary part times I, and the imaginary part b is a real number. So let's square both sides of this equation, because I don't like the fact that we've got this square root. Okay, so if we square the left hand side, we're just going to have 3 plus 4i equals, square the right hand side and we'll have a plus bi squared. So we're going to have 3 plus 4i equals a plus bi times a plus bi. So you can see now that actually this looks like a question where you could use comparing coefficients, equating real and imaginary parts, because we've got these unknown real numbers a and b. So we've got 3 plus 4i equals a squared plus abi plus abi and plus bi squared. Bi times bi is bi squared. Sorry, b squared I squared. So we're going to have 3 plus 4i is equal to a squared plus abi plus abi, and I squared is minus 1. So I'm going to write that as minus b squared. Okay. So next we want to make it really clear on the right hand side what's the real part and what's the imaginary part. Well, the real parts, the part without iron, is a squared and minus b squared. So a squared minus b squared, and that's the real part, and we could put it in a bracket to make it really clear. And then we're going to take I outside of a bracket here, and we've got ab plus ab, so we've got 2ab times I. So next we can compare real parts. So the real part on the left hand side is 3, and the real part on the right hand side is a squared minus b squared. So from that we know that 3 is equal to a squared minus b squared. And we could also compare the imaginary part. On the left hand side, plus 4 is the coefficient of I, the imaginary part, and on the right hand side the coefficient of I is 2ab. So we could write a second equation. We know that 4 is equal to 2ab. And then all that's left to do is try and solve these equations here. So we know that we can solve these by substitution. So if we look at equation 2, I'm going to rearrange it to get a is equal to 4 over 2b, or 2 over b. And I'm going to substitute that into equation 1. So I know that 3 is equal to 2 over b squared, just using this equation here, and then minus b squared. Okay, and then we can write this fraction out as 4 over b squared, square the top, square the bottom. And then I'm going to times through by b squared to get rid of this fraction. So we'll have 3b squared equals 4 minus b to the power of 4. And then I'm going to take everything over to one side, and we'd have 4b squared, b to the power of 4 plus 3b squared minus 4 equals 0. So this type of equation is a disguised quadratic or a hidden quadratic, and you'll come across this in a few topics in further maths. The reason why this is a disguised quadratic is because if we could write it as if we let u equal b squared, then you'll notice that u squared is equal to b squared squared, which is b to the power of 4. So you're going to have u squared plus 3u minus 4 equals 0, just replacing b to the power of 4 with u squared and b squared with u. And now you can see that actually it's just a quadratic. So let's solve this to find out what u is. We're going to get two solutions for u. We're going to get u equals 1 or u equals minus 4. So we wanted to find out what b is, not what u is. So we're going to go back to u is b squared. So we're going to have actually b squared equals 1 or b squared equals minus 4. So from this equation, b squared equals 1, we're going to get b equals 1 or we're going to get b equals minus 1. This equation here would have two solutions. We would have b equals plus or minus the square root of minus 4, and the square root of minus 4 can be written as root 4 root minus 1. So b is equal to plus or minus root 4 is 2 and root minus 1 is I. Now the problem with this is a complex number, and if you go back to the start, we said because we want this complex number a plus bi, a and b are real numbers because they're the real and imaginary parts which are real numbers. So actually we know that this part here where b is 2i or minus 2i, this is actually no solution. This doesn't help us because we want b to be real. So we know that b is equal to 1 or b equals minus 1. So all that's left to do is find what a is. So we can go back to using this equation here for a, using the fact that a equals 2 over b. So if b equals 1, a equals 2 over 1, which is 2. If b equals minus 1, then a equals 2 over minus 1, which is minus 2. So remember, we were looking for the square root of 3 plus 4i. Okay, and we know that that was equal to, we said that that was going to be equal to a plus bi, this complex number. So we know that a plus bi is either equal to, or we could have this pair of solutions, a is 2, b is 1, so 2 plus 1i, so just 2 plus I, or we've got another solution, a plus bi equals a is minus 2 and b is minus 1. And then it's a good idea to check that this works. So let's check that this works. So if we square this number here, we should get 3 plus 4i. Because remember, this basically means that if you square both sides, if you square the square root, then you should get 3 plus 4i. So if we do 2 plus I and square it, we're going to get 4 plus 4i plus I squared, which is 3 plus 4i, because I squared is minus 1, so that works. And then we could also check minus 2 minus I. If we square that, we're going to have 4 plus 4i and plus I squared, which is 3 plus 4i. So that works.